Good morning and welcome to today's session on extending ArcGIS Server. My name is Shreyas Shinde. I am an engineer on the development team at Esri. And today I'm joined by my colleague Carsten, who works as a professional services engineer with Esri. And to give you an unbiased view of the technology that we are about to present, we have one of our business partners, Stefan Bloom from Contera, uh, to talk to you about how their experience has been using server objects, interceptors, and extensions. It is not our intention to freeze you to death. So if you find this room unusually cold, I think it's something to do, some funkiness with the HVAC. So let's begin. The agenda for today is giving you a brief introduction about the extending capabilities of the ArcGIS system, looking at geoprocessing tools, a brief look into the geoprocessing tools, spending a little bit of time on server object extensions, and most of our time today in server object interceptors. And of course, sort of reiterating or reinforcing the point with demos at regular intervals. So before we begin, how many of you are ArcObjects developers, proficient ArcObjects developers? Okay, now I'm really afraid. How many of you are like first-time developers who have never worked with ArcObjects before? Okay, cool. So what I plan to do is I plan to give you a crash course in introduction and what it looks like, and then give you a pointers and documentation guides to sort of dig deeper on your own time. So ArcGIS is a very powerful system. It's a system of engagement that allows a variety of applications to perform or connect to ArcGIS for their geospatial needs. From analysis to visualization to storage, we support and developers can build a variety of applications, from desktop applications to mobile applications to web applications. And there are many sessions in this conference that will sort of give you a view of what you can do at this level of engagement. It's a system of insights, which means that it has built-in analytical tools and user experiences that allows you to peek into your data, to peek into your geospatial data and gather some intelligence or gather some insights about your data. Perform geoprocessing analysis, perform analytical tools using geoanalytics, raster analytics, using the Insights web application. So that's a pretty powerful aspect of a geospatial platform like ArcGIS. But at the heart of ArcGIS, it's a system of record. It is the system that stores your geospatial information, that stores your historic data, that stores your asset information, that you have come to bank on for time and time again. But it's also a very large API. You can think of ArcGIS as a very, very large API. And this is really exciting from a development point of view because you can programmatically access a lot of functionality that's available within ArcGIS, right? Now, because it's an API, you can create new applications. You can create mobile applications, desktop applications, web applications. So this work at the system of engagement level, which are actually engaging or interacting with your ArcGIS system. You can take existing applications or customize them. You can change the look and feel. You can use application templates and so forth. You can customize them. And lastly, you can extend the existing capabilities of the system as well. As developers, you have the ability to extend what's not available out of the box. And in the realm of extensions, I think what is available to you is to build geoprocessing tools or analytical tools, to build server object extensions and build server object interceptors. I think we are going to focus a majority of our time today, or most of our time today, in this extension aspect of the platform. There are many other sessions that are available that sort of highlight and talk about the create or the customize sections, but we won't be talking about that. So the first question that we must answer is why extend? Why do I need to extend the ArcGIS system? ArcGIS system, you need to think of extending the ArcGIS system when the out-of-the-box geospatial capability is not enough or not adequate for your needs. You may have needs, or you may have custom business logic that needs to handle security or more analytical capabilities, or maybe some QA back office QA QC workflows, or simple notifications that you want to be notified when certain actions or events or things that are happening within the ArcGIS system, you need to be notified. You may also want to think about extending the system if you have developers in your organization, Java developers, .NET developers, Python developers. And you want to extend the system if you have a little bit of experience or want to dig into ArcObjects API, right? Some experience with ArcObjects API. So let's sort of set aside, when you think about extending, I think we really want you to focus on your core business logic. We don't want you to be worried about, what frameworks do I need to use? How do I deploy it? Will it be scalable? What is the granularity? What is the isolation? All of it is handled, excuse me. Excuse me. All of it is handled for you by the framework itself. We have a very powerful SDK that's available in Java and .NET that gives you basic boilerplate code, gives you templates. It gives you your IDE integration. Excuse me, shouldn't be losing my voice on the 8th slide. So we really want you to focus on writing code, because a lot of things that you need not worry about is handled for you by the framework itself. So what are your options? First and foremost is building geoprocessing tools. You build geoprocessing tools in Java, in .NET, in Python, because you want to extend or bring in more analytical or data management capabilities to the platform. Something that's not available out of the box, or something that's not specific to your needs. You can build geoprocessing tools in desktop and publish them as geoprocessing services on the server. The next sort of set of extension points are server object extensions. Now these have been around for a while, since 9.2 release of ArcGIS. And we'll spend a little bit of time reviewing what they are. And most of our time we are going to spend on server object interceptors, which are not exactly new at 10.5, but they are relatively newer than the other technologies that's available. So let's begin. Anybody familiar with geoprocessing tools? What do you use to write geoprocessing tools? Python? Java? .NET? Just a few of you. Well, you can write geoprocessing tools in all these languages. Python being the language of GIS, it has access to more libraries, and that's where majority of you work in that space. But you can also write geoprocessing tools in Java and .NET. They need to be written, they need to be deployed on desktop, and then you can publish them as services on your server. The cool part about these tools is that in addition to the ArcObjects API, you can bring in your own libraries. Like Python has statistical libraries, machine learning libraries. You can bring those into your tools. These services, when published on the server, automatically are asynchronous by nature. So it's a sort of a batch system where you submit a job to the geoprocessing service. It gives you a job ID, and then at the end it gives you a result with a status, right? And they scale based on your needs and based on the load on your system. So you as developers or deployers of the system, set the min and max instances on your geoprocessing service, and the system will scale based on the load in on your system. You don't have to worry about specific scalability of your code. Server object extensions are the next extensibility points in ArcGIS, and they've been available since 9.2. Now, server object extensions they add new geospatial capability to the system, something that ArcGIS does not have out of the box, or something that's not available to suit your needs. And when you are writing server object extensions, you are basically building new APIs or new endpoints, as we will see. And you need to build custom tools or applications to consume this new API that you are building. So let me walk you through what it looks like when you are developing and deploying a server object extension. So here I have a GIS server, I have a map service, I have some image services. Now these publish a well-defined RESTful API for the clients. And so we have a variety of apps that can consume and connect to this API, and from web to desktop to mobile. Now when you write server object extensions, they get deployed and they attach themselves to the map service or the image services. But because they attach themselves, they are exposing new APIs that our built-in applications are unable to talk to, or they don't know how to talk to these new APIs. So what you need is custom applications. Either it's a desktop plugin or it's a custom web application that's connecting to your custom API written as a server object extension. So why write these? What is the benefit if out-of-the-box applications don't work with these new APIs? Well, you are writing them because you have advanced editing needs. You have certain rules and business logic that need to be applied when data is edited through your endpoints, something that's not available out of the box. Or you may have custom or advanced symbology or rendering that you may need to do that's not available out of the box. Advanced raster functions, so you have a specific function that needs to be implemented that's not available in our toolkit. So you can implement it, using a library of your choosing, or it's a custom algorithm. Data extraction is another very important aspect, which is you want to do certain things with the data that's flowing in and out of the system, but you want to sit very closely with the core implementation and the core data itself. A lot of what we see is also in the realm of raster management. You can write server object extensions for your raster services, for image services that act on your rasters, and you want to either apply some new custom tools, or you want to manage your set of rasters and expose them as custom APIs to your applications. The next bucket of extensibility or extension points is server object interceptors. And this is where we are going to spend a majority of our time today. They were available or first introduced at 10.3.1, and their purpose in life is to intercept the request and the response that arrive at map and image services. They don't expose a new or a custom API. Well, what does it mean? Well, if they don't expose a new or a custom API, that means existing apps continue to work. That means existing apps continue to work, but your code has the ability to intercept calls as it goes through the system. How many of you watched the keynote today? Right? So one of the things that the keynote speaker Todd mentioned was PubNub has this blocks concept where you can deploy this custom logic to intercept streams as they are flowing through the system. This is very similar to that, which is as your requests and response are flowing through the system, you have an ability to tap into it and filter it or intercept it and reroute it if needed. I think one caveat here that we need to mention is that it does not work for tiled map services. If you have map services that are completely cached, there is no ArcObjects code there. They're completely served out as a web server, right? All the images are cooked, extents are received, and we completely serve it out as a web server. And it does not work for hosted feature services right now. Hosted feature services are implemented not using ArcObjects technology, but a different stack. And that does not have access to the ArcObjects SDK at this time. So let's take a look at how these differ from server object extensions. So once again, I have a GIS server. I have map and image services. This is a well-defined API that's available, and apps have been written for this well-defined API. So when I defined a custom server object interceptor, it sits between the application and the map service. And as a result, existing apps continue to work. So the apps are not even aware or should not be made aware that there is some custom logic or code that's sitting between the endpoint that they are hitting and the app itself. So this is how it works. I have a GIS server, and all GIS servers have a REST endpoint or a REST handler, which is a web application that receives all your HTTP RESTful requests. Your map and image services are usually deployed in a container process called as the ArcSOC or Arc Server Object Container. Within it is your real map server object. Now this is an object that's tied to a specific map or a specific raster mosaic dataset or a raster dataset. So this is what your map service is made up of. This exposes calls from your apps to the map service object. So when you write an SOI and deploy it into the ArcSOC process, it's actually using the same process space and very closely sitting next to your server object. So let's say I have an external database that contains some basic rules that need to be applied as requests flow through my system. I don't want to code all of it in my SOI. I want an external system where I can look up a rule and apply it as needed. So when the request appears or are made by the apps, they are first intercepted by the REST handlers, and the corresponding REST handler will route it to an appropriate ArcSOC process to handle your request. When it arrives at the ArcSOC process, it's first intercepted by the code that you've written as an SOI. And that SOI can then look up a rule engine, look up a database, look up an external source, and determine how best to process your request. Your SOI can basically terminate that request right there, simply return a response, or process it further. So it can pre-process it and send it ahead, or delegate it to the map service object to do its work. The map service is going to do or handle the request, but then again your SOI gets a chance to sort of post-filter your response before it goes back to the client. Once again, it can look up a database or act on it as needed, and then send the response along its way to the client. So your SOI really masquerades and sits in between the REST handler and your map server object, and it filters requests as well as the ability to filter responses as needed. So why write them? What can you achieve by writing SOIs? Well, the first and the biggest request that we hear from our customers or from you is, your out-of-the-box security model is not adequate for my custom needs. So maybe I want a more fine-grained control on the layers in my map. Maybe I want a more fine-grained control in the attributes of feature classes in my map. The other aspect is simply filtering content. I want to hide certain attributes from being served to one particular role or a particular user who is requesting a map. Post-processing is another step, which is I want to apply a watermark, or I want to alter the image or alter the results in such a way that my clients, different users will get a different view of what the map is. Another sort of very simple idea is notifications. As requests are flowing through the system, you or your back office system needs to be notified of changes, or wants to be notified of events that are occurring on your map. Maybe certain extents are being requested more frequently. Maybe as features are being edited, you want to perform QA/QC on it, or you might want to rebuild a certain network. You want to be notified of doing that. So you can implement that. And lastly, we often have the need where we have asset information which is spatial, like a sensor or a city, and then we have observation information which might be attribute based, non-spatial. And not every time it's possible to shove all the attribute or observation information inside a geodatabase that can be served out by maps or image services. They might be located in completely disparate or different systems. Then you want to coalesce and return it to the client as a single entity. And we are going to take a look at this particular example in the demos. So as developers, you start by using your IDE, get the appropriate SDK, either Java or .NET. You then implement specific interfaces that are requested from you, and we'll go over it in a little more detail. You package them with a SOE extension. It's a custom extension that tells the system that this is an extension for server. You are then ready to deploy your package or your extension. And you upload it to your server manager, test it out configure it on your map service, test it out, and of course it works perfectly every time, the first time itself, right? So this debugging step is for amateurs. But there is debugging available. That means you can enable debugging on your server. You can attach breakpoints in Visual Studio or Eclipse or any Java IDE of your choice. And you continue the process till you get it right. Let's talk about interfaces for a little bit. So as an server object extension interceptor writer, any code that you write must implement these 4 interfaces. The first one is the server object extension. The framework uses it to identify what code constitutes a server object extension, and you pretty much have the init and the shutdown methods to implement. The caveat with the init method is that it must be quick, because it's invoked when your application or your ArcSork is first started. So we don't want you to do a lot of initialization. Like, don't try to connect to databases or do a bunch of analytics right up front, because that will time out your startup process. The REST request handler is your gateway into REST handling of your REST API for your application. So map and image services expose a well-defined REST API, and a REST API doc is available for your review. So when any REST API is invoked on a map and image service, it's intercepted by this handle REST request method. Excuse me. And there are parameters on this method that give you access to the payload, the HTTP request parameters, query parameters, which was get or post, content types, and so forth. And you can return the same along the way. The request handler 2 is if all map and image services expose an API that allows them to handle requests from desktop or ArcMap or Pro. Now these requests are string or SOAP payload, or they can be a proprietary binary format as well. So if you are expecting your client applications to be desktop or pro, you must implement this, or you need to block it. If you don't block it, requests will continue to flow through the system and you will not be notified, or your business logic will not get applied. Lastly is the iWeb request handler. Now this is for handling of OGC style requests like WMS, KML and so forth. So you can of course intercept KML and OGC style requests as well as they flow through the system. So once we have the implementation ready, we start packaging them, and there are packaging tools that are available in the IDE or in the language of your choice, Java or .NET. And you package them as an SOE and upload them through Manager. Once you upload them, they start showing up as a capability list on your map and image services. And then you add them into you enable those capabilities on your map and image services and simply restart the service. And then you're good to go. So before we jump into demos, I want to highlight this one new aspect that came a little later on after 10.3.1, that was Server Object Interceptor chaining, Server Object chaining. This we introduced at 10.4, and it allows multiple SOIs to be linked together. Not just one SOI, but multiple SOIs. Well, why is this important? Well, it's important because you may not develop all SOIs in-house. You might write some, you might buy some from the market, buy some from other vendors. But you still want to apply them in your processing chain for your requests. And this interceptor model allows you to sort of chain your requests together before it actually is handed over to the map server and so forth. Interceptors can be repeated. Now this is an interesting pattern, and I'll come back to it when we talk through the internals about why it's important that they get repeated. And starting at 10.4, this is a general sort of a statement, which is starting at 10.4, only administrators can deploy custom extensions. Can you think of a reason why it would be bad if we allowed any publisher of content to write and deploy custom code to the server? Right? Wouldn't be good for the health of the server. So only administrators can do that. But an administrator can then say that, no, we have well-trusted publishers. It's a small group, and I would like to allow these publishers to write and deploy content and code as well. And they can disable the flag if needed. Okay. So chains, excuse me. So just like before, we have a GIS server. It has a REST handler. It has a map service object. But here, instead of one SOIs, I have two SOIs. So the request comes in, it's handled to the first in the chain, and it's not a random picking. You decide the order in which your SOIs need to be chained. This SOI is looking up a different database for doing its work. When it's done its work, it can basically say, well, I want to terminate that request then and there, or I would like to forward it to the next in chain. And so it keeps repeating for as many instances of SOIs you have, eventually going to the map service object. And likewise, as the response goes back, it simply flows through your system and gives you a chance of intercepting again. Now, the idea of repeating is important because if, for example, your SOI 1 was a security SOI that did something pertaining to security, you don't want a downstream SOI to alter that, right? And so anything that's downstream, you still want to get a chance to make sure that when the response goes back to the client, that your SOI, your security SOI, still has access to make sure that the content that's flowing through the system is valid and it's acceptable to your organization. That's why it's important that if you have a security SOI, that they can be repeated as many times as you want. And goes back to the client. So enough of slides, right? We really want to see some code and how to get started. So my job today is to actually focus on how to get you started and give you an example of what's possible. And Carsten and Stefan will sort of take it further and introduce some more advanced capabilities. Okay. So the first thing that I wanted to talk about was how do you get started? So if you look at the server documentation online, either on server.arcgis.com or within your installed products, there is a topic on server object interceptors. Now they talk about why you need an SOI, what can you do with it, and how do you start developing an SOI. So in this documentation, there is usually steps for developing and deploying extensions. And if you were to sort of follow this to the T, the first step is that it says that you install the SDK for the language of your choice. You write the code, you package it, and you deploy it and enable it on a map on an image service. Simple steps, except the part of writing the code, right? The deployment is easy. You are still responsible for writing the code. So let's get going. So I have installed the .NET as well as the Java SDK on this Windows machine. It has the 10.5 ArcGIS Server, portal, and the enterprise installed and configured. So the developer kit, it comes in two flavors, Java and .NET. Depending upon your language, you install one or the other. So in the samples, actually, when you install when you run the installer, it leaves behind zip files that you need to unzip to open the samples up. So there is a sample that's interesting to me, which is this contains samples for both SOIs as well as SOEs. Now one sample that we've written is to apply a simple watermark to an image that's been returned by a map service. So I go into the folder, and it's a .NET solution that's ready to go. So let me first build the solution just to make sure that everything is working right. And let's try rebuilding the solution. Yeah. So the out-of-the-box solutions should build like right off the box, right? They are not expecting that you write code or do anything. So it's good to go to begin with. So start looking at this. So here is a simple class that's an extension, that's an interceptor, and that's implementing the interfaces that I mentioned: iServer object extension, iREST request handler, iWeb request handler 2, and so forth. Now when you start with, we recommend that you start with one of these templates as your starting point. You pick a sample, then you start editing code and begin from that point on. Now the idea is actually very, very simple here, which is it simply, of course, logs the request. It simply invokes for every export map request object. Every time your map server is producing a map that's an export map image type, it sends the request as is to the map service, gets an image, and then applies a simple watermark to that image at the end. So what this watermark code is going to add a copyright ESRI incorporated on the left screen. It's a simple watermark, and it sends that as an image back to the client. So you have not done the grunt work of actually computing the map. That's done by the map server. You are simply post-processing it and applying a watermark. So when you are done with So because I have built it before, when you build it, what it creates is a .SOE file. So your code is built into a DLL and it's automatically packaged as a .SOE file. A .SOE file is just a zip file that contains your DLL plus some added configurations, some more information about what your SOI does. The next thing that you need to do is go into your server manager through the site configuration. In the extensions menu, you simply add the extension and point it to your SOE. So I have already deployed the .NET apply watermark SOI, and I'll just show it to you. So I'm just using the sample world cities that's out of the box. This is an example of, again, like if you are getting started, the best example is start from a sample, use the sample service that's already available and start deploying your SOIs there. So in the capabilities section, you can see that there is a new section that says interceptors, and you can move it into the list of enabled interceptors. So the UI is designed so that you can chain things together and even repeat it if needed. You then go ahead and simply save and restart that service. And you can even mix Java SOEs with .NET SOEs in the same service, and that's fine and accepted as well. So it's going to stop the service, edit the configurations, add your interceptors, and then start the service. And this should take a few seconds to start. While it's starting, so this is an ArcGIS Enterprise install. So it is a server that's federated with a portal. So I have the sample cities as a map service here. And once it's started, yeah, it's done that. I'm simply going to open that service in a new map. So draw the layers of that service. Okay, so it's a simple standard service, but you will see that at the end, on the bottom left, you will see the watermark, that is the ESRI incorporated watermark that we added in the sampler template code. So we do know that the SOI is deployed straight out of the box. You can just compile it, build it, and deploy it. So I think this is a very simple example to get you going. Like all the bits are there installed. All you have to do is simply take it, deploy it, and try it out. But of course, we aren't going to get paid to add like simple watermarks, as developers. So the next idea is to think about mixing geospatial with observation data. So here is a concept implementation. So I have the cities in my map, but each city has some observation data, maybe some healthcare index or some rainfall index or pollution indexes that are available. Now I would like to blend the spatial information about a city or about an asset with these observation data that's not stored inside the geodatabase. Well, where is it stored then? Well, I have some information stored inside a DynamoDB table. That's an So I have a table stored on DynamoDB on AWS. It's a very fast, attribute-based database that's available for me, and it's very good to quickly store, vast volumes of information. Now, for every city, I'm maintaining the healthcare index and the pollution index. Okay, so this is information that's available outside my geodatabase, but it's relevant to somebody viewing a spatial map. How do I bring this thing together? So I've written a Java SOI called Enrich Features SOI. that implements the same interfaces, extensions. Now what this does is this extension actually connects out to the DynamoDB web service and blends that information into a seamless experience or a seamless model for feature schemas for my feature services. So let me show you what the REST handler does. So what the REST handler is doing is it's bringing in these new columns of the healthcare and the pollution index without actually telling the feature server or the map server that these tables actually exist, these attributes even exist. So when calls need to be made on a feature server, you need to sort of take these columns out. But when they need to be advertised to a client, you need to add these columns and say, well, this city has, in addition to the attribute information that it's getting from the geo database, it also has additional columns that are coming from some other source. Now, anytime a query operation or a layer information is made, so this is the query operation implementation. What it does is it calls the DynamoDB client, gets the information, that's the index key, either a city name or a city ID, and it gets information about the healthcare index and the pollution index. And it adds it to the response and sends it back to the client. So it's getting everything from the geo database, but it's appending or augmenting that information with information from DynamoDB and sending it back to the client. Now, I've also made a simple Maven script, a Maven deployment script or a build script that can be used to simply build this application because it needs to be done repeatedly to get something right. So if I type Maven clean package, it will build the Java code. It will build that Java code and create me an SOE package. So I have a Maven file attached as well as a part of this, and I'll make it available when the presentation slides and samples come out. So this is my project, and under the target folder, you can see that there is an SOE file that we just built at 11:12 a.m. today. This SOE file is now ready to deploy to my manager application. So I come in here, go into my server manager. So follow the same process of registering that extension by going into the site resource, into extensions, so that SOI is already deployed, and I can go ahead and enable it on my map service. So this is also an example how things are chained together. So I'm still getting the watermark if I have access the map endpoint, but I also get the feature endpoint with the augmented information. So I'm going to save and restart this service. And on the same map that I had before, I'm going to add a reference to the layer that's pointing to the cities layer inside my map. So once the starting is complete, I can go to my REST endpoint map server, and I know it's the first layer. The cities is the first layer in my map service. I'm going to copy this URL. Oops. And add it to my portal. Actually, browse for layers from the web and paste it. Sorry? Oh, did I miss the layer ID? Okay, let's try it again. Sorry, thank you. Okay, well, it should have worked and should have augmented that information. So what I'm going to do is stop right here, debug my application, figure it out, and hand it over to Carsten to take it from here on. Thank you.
Thank you, Shreyas. I think I will try to squeeze my content in about 5 minutes.
Okay.
So we have enough time for Stefan to do a little bit of his part. All right. So last year I showed something that was based on an actual project that we did. It was a security server object interceptor, but there's a lot of overlap with what Stefan is going to show. And B, I thought I'll do something that's more along the lines of the art of the possible today. In previous projects, what I wish I would have had was a facility that allows me to take a bunch of points and put those on a map in a in a manner that's easy to understand, that's visually easy to capture. So obviously within the web API, so this is for a web use case. Within the web APIs that we have, the JavaScript API is probably the most popular. And of course, I can go to a feature layer and display all these features on the map. But that starts to not work all that well anymore when we talk about multiple tens of thousands of features or even more than that. There's some time required to stream this data to the client, and then the client also needs some time to display this. An alternative is to just use image layers, so export the map on the server into an image. But again, you see a bunch of points and probably not be able to tell the forest for the trees. There are some client-side workarounds for this. So there's a cluster layer example out there that a lot of people are using. There's a heat map layer example, but again, all this processing of that data happens on the client. So all this, tens of thousands of features have to be downloaded to the client first before they're being processed. Yesterday, you might have seen the new WebGL-based feature layer that's coming. That's probably going to solve some of these problems as far as the client-side processing is concerned. But maybe what I'm going to show you has another lifetime of 3 to 6 months until this is released. On the server side, there are some out-of-the-box options as well. So people have used a technology called query layers to basically summarize the data on the fly on the client into, let's say, admin boundaries or some kind of hex bins. Or you could do geoprocessing to summarize the data. But here I'm going to show you a clustering example. So real quick, the clustering algorithm is pretty simple. It looks at a bunch of points and it creates a grid across those points, a regular grid. And then each point that falls into a cluster cell gets assigned to the cluster that owns that grid cell. And there's a little bit of shuffling happening so that they don't overlap and they look a little bit naturally positioned, but essentially that's the workflow. One second. All right, let me show you the code real quick. A colleague of mine has been maintaining this sort of cluster example that we've been using in services for a while in a JavaScript version. And I asked him to translate that to Java. So there's this cluster assembler, and basically you have to give it a bunch of point features that have an attribute, and it will then do the clustering logic. I will show you what the thing looks like in total, but one thing that I found pretty useful is to sort of test your code in a unit test type of fashion. Here I have just a simple one that's just based on the main function, but it will retrieve about 15,000 points from a feature class. Do the clustering, and we could see it created about 23 clusters, and that took 4.2 seconds. I think it's like 16,000, almost 16,000 features. So you've seen, Shreyas has shown you the build logic, so I'm not going to, sorry, the build process. I'm not going to go through that one more time. But actually, one thing I forgot to show on the slide is, let me show this again. The reason why this is a server object extension and not a server object interceptor is because I need some additional parameters. So I'm extending the API. It looks similar to the feature query endpoint, but I need to know what field to cluster on. So for example, that could be a valuation field that tells me what a specific location is worth. And if I cluster on that valuation field, I need to sum that up for all of the points that fall within that cluster. In order to generate the grid, I also need to know what the screen looks like on the client. So I basically need to know how many pixels high and wide it is, and that's this sort of map units per pixel and cluster distance and pixel parameters. So there are basically 3 additional parameters that I needed to implement here. Let's look at what this actually looks like in the real world. So I have here a drop-down that lets me pick some of these. Of course, it doesn't work right away. Wouldn't be a demo if it did. Let me reload. So I have these 15,000 permits that were issued at the city of LA since the beginning of the year. And here I've summarized them into a handful of clusters based on the valuation, but I can also, for example, look at the number of residential dwelling units. And if you look at the developer toolbar, let's look at this very quick. Pending. It should take about 4 seconds or so to process these 15,000 features. I've been tinkering with this a little bit. It starts to sort of get a little bit slow when you get to 150, 200,000 features, but it works pretty well for sort of 10 to 100,000 features, I would say. So I'll just sort of stop here, and Stefan, maybe if you want to take over.
Thanks. Thanks, Carsten. Great. So as we are quite far in terms of timing, I will also try to quickly run through my slides without forgetting the essential parts. So my name is Stefan Blume. I'm working at Conterra in the technologies branch, and what we did, and what I want to tell you today is about our experiences with developing an SOI product that cares for fine-grained access control for ArcGIS GIS services. So security was already a topic by Shreyas here, and we are coming to have a bit history here. Conterra is a part of Esri Germany group, and we have a lot of experience with GIS server security. We have a major product that's called security.manager that can be understood as a proxy component to back-end GIS services, and there we have a history of more than 10 years. So once the SOI concept was introduced, that was quite clear to us that we need to apply to that technology because it gives us major advantages about the proxy approach. Yeah? So we can transparently integrate with server technology. So we started prototyping and to understand how quickly we can solve that problem, or how we quickly can create a product. And that was quite successful, and we saw, okay, we can reuse a lot of parts of our pre-existing enterprise edition. And so the product was released in 2016, the SOI product. To tell you where we're coming from, you can see here the enterprise edition. That is a proxy that runs in front of your server landscape, and that is also intercepting requests, but it's an infrastructural component that comes additively to your infrastructure. And with the SOI approach, we have the chance to not only integrate smoothly with ArcGIS Server, we can also integrate with the authentication mechanisms of server or even either portal if they are being federated with each other. So ArcGIS Server is caring for authentication, our SOI is caring for authorization. The goals we had also in terms of business goals were, so we wanted to have comes out of the shelf product that is really easy to use, easy installable, even easier than our pre-existing product, and it should be applied, of course, for server and for portal scenarios as well. So that is, of course, very, very important. And we wanted to be quite quick at the market to say, okay, Conterra has the security stuff, and also for a server, of course. In terms of functionalities, we are supporting feature server and map server REST endpoints. And yeah, in the future, we will quite carefully listen to what our customers are saying. What does it mean now then in terms of fine-grained access controls? You can control the access to certain layers for specific users and roles and groups. And also you can decide that for a specific feature. That means you can inject definition queries on runtime when the request comes in to the SOC process and modify the request that is passed by the client. And also this is not doable by definition queries, but also with spatial queries. So I want to continue with a quick demo to give you a better understanding what's this for. So imagine you are exposing a service caring for, exposing information for a power network, and you have a lot of people, a lot of roles, a lot of responsibilities, how those people do interact with the service. And of course, you want to bring a major advantage into the system in terms of that you just maintain one single service that can be tailored for your client's needs in terms also of data security and also in terms of focusing on specific aspects of the service being exposed. Okay. So I have opened the ArcGIS Manager, and we have this Power Network service here. I will proceed into the administration. Sorry that this is in German, but I think the key aspects are very clear. We have an SOI called Enhanced Security here. That is already activated. I can click on it, and then the properties that are being stored with the SOI become visible. We decided to go for an external administration of the rights and access rights to the service because of the complexity of what you can do for enabling access to the service's resources. So I do need to log in. So this is not yet SSO integrated, but it's authenticating with ArcGIS Server. On the left-hand side, you can see all the roles that are available. This is a federated server with a portal. And on the right-hand side, you can see the resources of that specific service. So I just want to tell you that, for example, if we highlight this Virginia Electric user, so this is a group where people employed at Virginia Electric are collected, so to say, in the portal. And once I click on that, I see in the middle of the screen the rights and resources that the administrator has designed to be available for the people from Virginia Electric. So you can see they are able to see the power plants and the transmission lines. And additionally, we have a definition query that shall be applied on each request coming in here. So you can see we simply inject a query like owner equal to Virginia Electric and so on. And this is also doable, for example, to switch to the California user. You can also apply a spatial filter here. So if I click on edit, we see that we have referenced a feature server here and its layer and a state name, sorry. And so on runtime, that query will be executed, of course, cached for performance reason, and then this extend is either added to the request or on the way back applied to the response. So let's give you an impression how that looks like for the different users. I will open that in an incognito window. So for example, there's a citizen user that I will catch up with on my password list. So this is citizen 01. And that user is able to see basically the power plants. So this can be a possibility to expose information for the anonymous users, for example, as well, yeah, or just basic users. Close that down here, open that again in an incognito window, pick up my Virginia user. And once the service is there, we will see that the extent is focused on, so it's not focused because it's not the spatial restriction. You saw we had a definition query limiting the feature response to the assets of Virginia Electric. And also, of course, this is then applicable to attributive queries, so that we only see all the features belonging to that specific company. That means you can simply tailor what the service responds to the different roles and users. It should respond. Yeah, there it is. Okay, good. That much for the demo. For the time, I will just quickly return to our to the PowerPoint to give you a short introduction what we did specifically. As I said, we have built on the Enterprise Edition, so we had a pre-existing amount of code that we wanted to integrate and that we successfully integrated. Architecturally, we are running a Spring container inside of the SOI, so that's possible. To totally confuse you, we also have an interceptor concept inside of our security manager that is bundling basically the interface-specific knowledge. So that was the major task, to integrate our interceptor to the SOI piece of code. As I said, we kept the configuration externally to the SOI. That basically had the reason because of complexity, and it gives us the possibility to script the policies and the rules that we want to apply to the service externally by a REST interface, and we are not depending on the, let's say, service maintenance and service administration of the ArcGIS manager. We skipped that development stuff at the bottom. With this oversimplifying diagram on the right-hand side, you can see that we have a bunch of code that we could reuse. And with that product, we simply added some glue code that picked up that what's coming from the handle REST request method that Shreyas introduced to you. And also on the way back, that we can deliver that byte array back to the SOI chain or even to the map server at the very end. Some key takeaways for you that we experienced with this product development. So from our understanding, the learning curve is quite steep, but once you are there, it's smoothly. Yeah. So don't give up at the very beginning. It's getting easier and easier once you are more safe with the system. And what you definitely need to understand is you're running in a Java virtual machine, and that has been created by the SOC process. So you have a preset class path, and you're not living in your own universe. You need to understand that this, what you are doing, what you are introducing with third-party libraries may interfere with components that are already there. Okay, and another thing that we also learned, SOI increases memory consumption. Be careful what you do, because if you are not, it can crash your server, and that is not that what you want to achieve with your SOI. So depending on what you are doing, and we were doing somehow cross-cutting concerns with security, try to mock what you are implementing. Yeah? So don't try to upload your SOI, test it, debug it, try to separate that and really reduce that debugging part as small as possible. Yeah. Okay, and we also saw it's the most easiest way is if every developer has his own ArcGIS server machine. So some things that we were missing. So I told you that we are coming from a proxy approach. So basically HTTP is the language that we are speaking. We would like to have more control on what the server is responding in terms of HTTP responses. That's somehow limited because we are in an artificial interface that's somehow abstracted from HTTP, of course. Yeah. So that's naturally what the system is designed in that way. Also, we would like to have streaming support. Currently, when you saw the interfaces, we are returning a byte array. Yeah, so, and that means that you, as SOI coder, you need to know the whole response are you carrying in your memory. Yeah, and if you want to, you cannot push the responsibility to deal with large amount of data to the client. Yeah, so you need to care for large and even larger responses of data, and you need to be aware of that. Okay, also it would be very nice, as you saw, we have an application that manages the rules externally. If it would be possible to have some kind of SSO with external or third-party applications then being triggered from the manager interface. Yeah, that's all what I have, guys. Thanks.
So we've gone a few minutes overboard. Thank you for sticking around and not rushing to your lunch. But we'll be here to answer your questions. If you still want to see the augmented demo, it's now working. Doesn't work the first time. That's a simple demo trick. But we'll be happy to answer your questions. So stick around. Do you want to have questions? Sure. Go ahead. I'm sorry. The question is the ArcGIS support Python 3? Okay, so the question is, can you write SOIs and SOEs in Python? There are no plans to support that right now, but if you have more and more need for doing that, we can take a look at it. Sure. The question? Yeah.
Yeah, it comes back as a feature set. Basically, the exact same response type that you get from a query operation or against a feature service or a map service. Yes, actually, I forgot to mention this. So that's on GitHub. If you actually, let me show you. But
yeah, all the samples that we showed today, at least one was in the SDK, but the augmented DynamoDB sample would be available in a GitHub repo that you can download and play with.
so if you see the slides, the link is on the slides too. I think we hand those out, or they will be for download, right? But it's github.com/esri/server extension Java. The one thing I didn't mention that was obviously a Java example, but the code would probably be transferable to .NET if you wanted to do that.
Any other questions? Yeah.
This is a little bit more of a comment. It was mentioned that if you want to pass in extra parameters that you need to write an SOE as opposed to an SOI, but there is an exception, and I utilized that for an SOI that I wrote. If parameters can be added at the sort of the feature level, for example, the network analyst problems are presented as features of stops or facilities or that sort of thing. You can actually sneak in extra attributes and they come in the JSON and you can actually see them and use them.
So I think that's a good point. And actually what I mentioned was that you can't change the API. So if it's an existing API that's taking a parameter, let's say an array of strings, you can always add more content to that. But you can't change the API or expect to have a new query parameter that's custom to your SOI, because the mapping applications will not know how to pass that in. Yeah, that's a good point though. So if it's an existing parameter, you can always augment it to have more values, but you can't add new parameters. Any other questions? Yeah. That's a good question. And the question is, if I'm using collector for data collection and synchronize that data, it usually makes a sync call on the feature service. So it actually makes the sync call on the feature service. And if you were to implement an SOI, you would have access to the payload that's been sent for the sync call. And that would be a SQLite database that you can peek into and do stuff with it if needed. But collector, when you do sync, does not break up your edits into individual little edits and send it over the feature service API. It actually invokes the sync API. Yeah. No, the sync API, the payload for a sync API is a SQLite database. So sync API takes in as a payload a SQLite that you need to upload it. And then you will need to peek into the SQLite database. Yeah. That's right. That's right. So when the collector goes offline, what it does, it creates a replica from the feature service. The replica is downloaded as a SQLite file, SQLite database. Collector works on the SQLite database, and when you invoke sync, it sends the SQLite database back to the feature service. It doesn't send them as individual edits.
Yeah, my experience with SOIs in general is that you get into deep waters pretty quickly, where these things are fairly challenging to implement, depending on what kind of REST operation or REST resource you want to intercept. And I think the sync is one of those.
I think I think customers have challenges with implementing SOAP or binary payload. That is a pain, something that I don't wish that any of you implement or go into. But if it's something that's needed, some SDK utility services and tools are available if you want to unpack and pack SOAP payload or binary payload for your desktop clients. Any other questions? Yeah. That's a good question. So, what's the performance impact of augmenting information from a different source as compared to adding, a dynamic workspace? So, I think the example that I wanted to highlight was your observation data is not in a geodatabase, right? And so you are doing extra work as a layer to get the information from a map service and then add on top. So it's definitely going to be slower because you pretty much have two computations in them. The map service does its work, and then you additionally go and get more data and augment that data and send it back. As compared to a dynamic workspace, well, if you have everything in the geodatabase itself, you can push it deeper into the map service and not need to implement it as an SOI. So that way, it's still the map service that's doing the computation. It may be much faster. But the example here was that you don't have your data inside a geodatabase. Because, well, we just showed the healthcare index and the pollution index, but you can also start thinking of, well, the index values are actually numeric values that need to be aggregated over time, and you can still push the aggregation in your SOI if you want to. Yes. Right, that's a good question. So this SOI is only applicable to ArcObjects based services, specifically map and image services. So if you are publishing map or image services exposed as map or image layers inside your portal, these SOIs and SOEs will still be applicable. No. So none of the tiled map services. So vector tiles are really served as tiles. They are pre-cooked images that are simply served as a web server. So that stack does not go through the ArcObjects stack and will not intercept. Your SOIs will not intercept those calls. Any other questions?
For the example of the security manager, it's mentioned about actually it requires more memory space because of the JVM. So just wondering actually, is it better to write the SOE, SOI as a .NET instead of Java?
Also, good question. So the question was if you have advantages from the memory perspective with .NET or Java. Actually, we are really Java settled, yeah, and our objective was to reuse the existing code. So we hadn't that discussion when it comes to the product. So we are running in a Java world. So maybe you can add something.
So any code that you write that runs inside the process, be it Java or .NET, and that something that allocates memory will go towards the memory that's occupied by that process. So it's not that writing it in Java or .NET is going to give you any more memory performance than writing it in any other language. So whatever you occupy, so let's say you allocate an array of 1,000 bytes, whether it's in Java or .NET, it's going to occupy 1,000 bytes for that process space. So it's not going to get you any more performance if you were to write it in .NET. There is no difference between Java or .NET. It's basically what you're familiar with. So if you have Java developers, if you are a Java developer, you are familiar with the tools, familiar with debugging of the environment, then I would say just go with Java.
Doesn't matter what servers you want to deploy it on, though. Like if job, if you wanted to run on a Linux server, then
Yeah, absolutely. So I think that's another consideration, which is if you are doing some sort of authentication or that can only deploy to, to Windows machines, then you can't write .NET code.
Another question is that most of your examples actually are making out decision numbers based on external data, which is not the same ArcGIS server. I just wonder actually if I have a situation that I need to retrieve the information from the same ArcGIS server to retrieve some information from a database. So I wonder what's the pros and cons actually, or you suggest that actually use external services to retrieve the information?
That's a good question. And the question is if the SOI needs to get some rules or some more information out of an existing ArcGIS system, what patterns are there? And my answer would be that, one way is that you can write an SOI that calls into another RESTful service that's powering some other data, let's say some other feature class that has the data that you need. So you can call back into the server over a RESTful API. The credentials are already passed in, so you can still make the calls to other services in your server if that's what you want. Actually, one thing that I wanted to note is SOI code or SOE code runs pretty much as an admin level elevated privileges. So we don't want you to do bad things because you're running elevated code. But that's what it does. Like SOI is considered fully trusted code of the server, and you have pretty much administrative access on your service processes. So you can call back into another process, or you can call back into other feature classes. You have full access to the server that way. All right. Do you want to stop now and then you can come here and ask questions if you want to?